It's recording now.
We had quite a few people asking through email if the sessions would be recorded because they wanted to watch it. And we thought we would leave them online for maybe a few weeks, but it's not going to be a permanent video. And the video is basically the person who's talking. So none of you are visible in that video. It just switches between the person whose sound is coming from. We'll wait, like normally, wait maybe a few more minutes, 2 or 3 more minutes. Yeah, people are joining us still. More and more people coming in. It's the tough survivors that are joining us today. There have been some people have dropped off, obviously, as we expected. And here we have the hardcore remainers. I guess we can just start now then. So I'm going to talk a little bit, then I'm going to hand over to Francisco, who's going to introduce the tutorial, and then Chris is going to end the session. Francisco has just uploaded a YouTube video with explaining the latest tutorials. So you haven't had chance to look at it before this session, and therefore we will do a slightly more kind of go through tutorial in this session. But the idea is, as we have talked about this, the idea is to try to explore how SEMA allows you to create your own programming language, mini language. And when in live coding, the history of live coding has always been about creativity in the tools that we make. So new programming environments, new live coding systems, new ways of expressing music through code. And people have come up, if you look at the past 15 years of live coding practice, there are so many new systems that have come out, all kinds of exciting experimentation. But the danger is when we start to get really popular environments that suddenly the music starts to become a bit more homogeneous, and the experimentation around new languages and new ideas disappears. And maybe that's natural, maybe that's good, but we also thought to kind of contrast that approach is to create a system where everyone can create their own language, where everyone can make an experiment with how to express music. And we think the live coding language can be as simple as a language that simply defines a bass drum, or a language that sends out some MIDI notes, or you know, you can make really small languages. We're not trying to, you know, solve every computer science problem with these languages. They're small tools or instruments for a particular purpose. And our experience of SEMA is that it's great to have this system to define our own languages. So that's what we're going to look into today. We're going to hopefully provide you with these tutorials and this session and the videos that we've uploaded, provided you with enough knowledge for you to make your own language. And we are hoping that some of you will join us in the new Network Music Festival in the middle of the month, from 15th, I think it is. Is that correct, Francisco?
Yeah,
Chris?
that's right.
15th of July, where we have a slot where your music and your new language or machine learning or simply playing with the default language, we can have some performances there. So that's basically what we want to try to do today, is to wrap up this knowledge that we need for creating your own language. And the next steps in the coming week, we have 3 sessions in next week. We will hope to help you with how to implement machine learning as part of your own language. So we're really interested in your experience. We're really interested in supporting you in creating your language. And we would like, if you want, we would like to include your language in the SEMA system. So we will have like contributions from users as part of the SEMA system. But we're really interested in your experience during this workshop and as a user of this system. Obviously, there are all kinds of usability issues with our system. There are problems with documentation, and we've addressed them during the workshop. But there's also the ideas of what does it mean to create a new language? Why would you do that? How would you want to use machine learning in your music? And those are things that are well beyond, you know, the product development of SEMA, which are much more philosophical around live coding and machine learning in general. So those are things that we really want to understand and talk with you about. So we're hoping to run this user study, a little survey, and perhaps a few interviews next week as well. Interviews later in the week, but the survey, yeah, the survey would come out by the end of the week as well. But that's enough to kind of start with. I think I'm going to hand over to Francisco, or did you want to say anything about the survey, Chris? Or am I forgetting anything? No. So I'm going to hand over to Francisco, who is going to go through the latest tutorial, the latest addition to the system.
Okay. Hi, everyone. Let me just share the screen. So, okay. Okay. Can you see my SEMA on my
yeah, it's looking good.
browser?
Yeah, all good.
Great. Okay, so the last tutorial that that was uploaded yesterday, or that we went through yesterday, we were looking at the language design workflow and trying to understand what was the Lexer definition, how the tokens were defined using JavaScript regular expressions to recognize the vocabulary of our language. And we managed to craft a 3-token language, which allowed us to perform with 3 samples. So basically, we're going to pick up at that point and add some new features to our grammar to make our language a little bit more powerful. So we're going to look more into the specifics of the BNF notation for specifying our grammar. We're going to understand better what are the code blocks that come with each grammar rule. And we're going to add a few features such as numerical values, other signal processing features, and so let's get started. Right. So yesterday our grammar was at the point that had 3 statement rule definitions. So we've seen that we have our token definitions for the lexer here, and for our grammar definitions, we had these grammar rules here and here. Can you see this? Is the font size good? Yeah. Oh, I can see the chat window. Right. So one slight improvement that we can make to our grammar rules, for instance, is that instead of having like multiple statements for the same symbol, in the case of statement, we can actually make multiple derivations for the same rule, like in here, like statement is click, or is convolution, or is hard. So that means that from now on, we have this symbol here, or, which adds multiple derivations to our rule statement. And that means that statement can be one of these 3 tokens. So if I try it out, I can still have the same thing that we had yesterday. Oh, oh. Oh, sorry. Let's see. Oh. Oh. Sorry, I think I have a few technical issues. Oh. Can you hear the sound now? Yeah?
We just now, but it's, yeah, we're hearing it.
Oh, okay. Right. So yeah, so back on track. We have the same tokens for our language are still operational with a slight tweak to our rules definition. So Um, so what are these? What are the differences between these three rules in terms of the code that's executing? So first of all, we need to understand what are these bits of code. And in our grammar definition, this is what's called semantic action. And the semantic action is something that when parsing is happening, when our parsing is breaking down and analyzing the string that we pass on the live coding editor, each time that one token is recognized and all the chain of rules that led to that specific recognition is backtracking. So these bits of JavaScript are being executed. So this is nothing more than a JavaScript function which is executed, which is an arrow function. So basically, it's more of a modern JavaScript version, but you can also define with a normal anonymous function declaration. So that means that when we're backtracking through the rules of the grammar, these bits of code are being executed. And this function specifically is creating a list. You can see that with the symbol of list, which has one object that has nested bits of JSON. So basically, this is how we create the bits of our syntax tree. And this syntax tree has to be built with specific rules that we created for, and you can actually know more about them in our documentation, which is at that link in this document. And we have all the types defined for SEMA, and this is how they're mapped to that specific JSON object that has to be created. So when we want to play a sample, we're basically spawning or creating a new signal processor that will have some audio output and which will play another block of signal processing, which is a function that loops a sample, a specific sample that has a specific name, and that has one parameter, which is the sample speed at the sample will be played. So when we're changing, for instance, to another sample,
Francisco, can I just ask for a clarification? That value loop there.
Yeah.
The loop is then the JavaScript function in Maximilian, in our signal engine, right?
Yeah, so our signal engine is receiving this code here on the orange window, right? So you can see that if I play heart, we have here a sample, which is there's a process in our signal engine, which is creating a Maximilian object, which is the maxi sample, which plays samples. And it plays a sample by its name from the sample set that we have available, and then plays that sample at the specific speed, which is right here. Right? Okay, so if we choose to play some other sample, click or convol, you see that the code that was generated just updated to have a change in the sample name. And so, okay, so this is the basic of what this simple language does. Right. So, for instance, if we want to make our language, if we want to add a new feature to our language, let's say I'm playing 3 samples, but now I want to play an oscillator. And so basically I'll have to create a new token, a sawtooth oscillator, let's say. And I need to define a regular expression that recognizes the string saw. And I need to add a block that plays an oscillator. So I'm going to copy paste this bit here. I'm going to add it, and we'll be analyzing that in a bit. So let's try it out. So if I write saw, so here we have the saw oscillator playing. So what is the difference between playing a sample and playing a sawtooth oscillator in terms of that intermediate language? So if we compare click and saw, we see that we have a new signal processor spawning, and we still have an audio output defined with the DAC function. And we're playing another signal processor, which is a little bit different from the sample playing, because the function that we're asking the signal engine to play is a saw. And we also have a numeric value at 10, which is the frequency of the sawtooth oscillator. So this little bit of code is different from how to play a sample, because, for instance, we don't need a name for the sample. We have a simpler function. So here we have our language just become a little bit more powerful, and now we can play the sawtooth oscillator. So this is simple, but what if I want to change the frequency of the sawtooth oscillator? So I could, for instance, go here and just edit our grammar, and as soon as I make the change, the parser is evaluated in real time. The grammar is evaluated in real time. A new parser is generated to analyze our live coding editor. So now we have a sawtooth generator playing at 100 Hertz. But okay, but this is not that interesting because I don't want to update my grammar just to have a change of frequency. So let's make instead our language capable of having a numerical value that can capture numbers from our live coding editor that can tweak or change the value in our saw function. So basically, I'm going to add a new symbol to our right-hand side of the statement rule to recognize a number after a space after the saw token. And I'm going to capture that by getting this little value, which is how I get the variable that comes from this number. So if I evaluate this with the new parser that's generated, oh, of course, I forgot something really important. I need to define a token for the number. So let's define a token for the number. So how can we define a regular expression for the number? So we can, a regular expression could be 0 to 9. Actually, yeah. Let's make this problem proof and just copy it. Okay, so this is a regular expression that basically recognizes everything after this symbol, and it recognizes one number between 0 or 9, or one number between 1 and 9, followed by one or more numbers between 0 and 9. Okay? So that's what the regular expression means. So if I now evaluate this, okay, so we now have a language that also enables you to control frequency of an oscillator. So let's just make sure. Yeah. 2, okay. Oh, and it still plays the sample. Okay, it does. So everything is smooth sailing, kind of. So what else? Okay, so maybe now I want to, instead of having to write a fixed definition for the Sawtooth oscillator, maybe I want to make this as a variable in our language, and I want to choose what other waveforms we can use with our signal engine. So for instance, so let's make this generic. Let's call this OSC for oscillator. So I will need to define a new token. So let's just replace this. And let's create a more expressive regular expression that just captures letters from A to Z, one or more. So this is how we'll get like variable names for our oscillator. So the token is taken care of. Now I need to capture the value of the oscillator. And so I'm going to grab the string that's being injected in the function, and I'll just replace that with the value here. So, right, that should do the trick. So let's test that. So this is playing. So how about an oscillator? Okay, it's playing a Sawtooth oscillator at 10 Hertz. And so let's try out sine wave at 440. Oh, cool, it's working. So triangle, square wave. Oh, okay, so square wave. Oops, okay. Equals. Okay, so this tweaking showed how we can quickly iterate on your grammar to have features to your language, and how to tweak the grammar rule definition to come up with to add more symbols to your rules, how to add new tokens, how to define new tokens with regular expressions, how to bind them to the grammar rule definitions, to come up with all these features in your language. So maybe it would be useful to ask if there's so I see that there are already questions on the day 5. Should we ask some questions now before carrying on?
I think the questions have been answered by you as we go along. there were questions about what about parameters, what about changing oscillators,
Okay.
what about maybe playback speed of the samples, but that's the same as with the frequency argument of the oscillators.
Yeah.
You could show that quickly, of course.
Sorry, I'm trying to find my chat on Zoom because I can't seem to find. So,
oh, here's a good question. What if you want a variable amount of parameters?
Yeah, so that's a little bit more tricky. We're going to have a tutorial on that. We're going to upload a tutorial on that, but I wasn't really ready to show that now. So maybe I'll just carry on with the recursion.
We haven't done any recursion yet, so now we're getting to that. Isn't that correct, Francisco?
That's right.
So that's a major kind of new concept that you're introducing.
Right.
With recursion.
So in the recursion, which is the next tutorial in our tutorials list, we're going to create a language, or we're going to push forward on our language. And so basically recursion it's a very important thing because it allows us to define lists. And if you want to have multiple instructions, for instance, for your language, that's how you create the list. So we're going to create a language that enables you to play lists of oscillators, and we're going to see that as we go. So this tutorial starts with the template in the grammar. The template for the grammar. We'll just copy paste this part here, and we're analyzing the code as we go. Right. So this grammar is a simplification of the previous grammar, and it enables us to just play a sawtooth oscillator. So and if we change, you see that the value is hard-coded. So if we change, we always have the same value. So if we move into a second iteration, we're going to organize our code a bit differently, and so we're separating the block that we had before into a process. We're separating the process and the parameters that exist in the final tree into a list, and we're breaking that piece of code into a variable that will be injected on the tree that's going to be returned. So this does exactly the same thing that we've seen before. Now, if we evolve a little bit further, we're going to grab that change that we're capturing the value of that token that we've defined, which is the number, just in the way that we've did on the previous tutorial. So Okay, so the next thing that we'll want to add is to give the possibility of playing more than one oscillator. And we're going to do that by just repeating those blocks and injecting them in the mixer block, which will be then injected in the final tree that's going to be returned. So now we have a language that captures numbers, but there are also a new introduction to the tokens, which is separator, which is a comma. And our grammar rule is taking that into account and grabbing the first value of number to the first oscillator there. It's disregarding separator, but accounting it. And then it's grabbing the third value for the second number, like so. So if we now add another number, we have a language that is able to play two oscillators. Right. So now we're going to add the recursive step. And let's see how that happens. So in the recursive step, we're going to introduce a recursive rule. That means that it's a rule that needs to have a derivation that makes use of itself. So we're creating a new rule, which is for a new symbol called oscillator list. So our statement derives into an oscillator list. And our oscillator list can be one oscillator followed by a list of oscillators. So this is the recursive step. So our oscillator was what we had before, that little piece of code that was a signal processing block with a function for sawtooth, parameters, and what the recursive rule is going to do now is it recognizes that oscillator and creates a list with the oscillator that it recognizes from this term. So that's what happens for one oscillator. When you have more than one oscillator, the list is just going to concatenate the first oscillator to the rest of the list. So the rest of the list comes from this part, and the tail of the list gets, the head of the list gets concatenated to the rest of the list. So if we have one, it's playing. If we add two, playing. 3, 4. Yeah, so that's a language with a recursive step that accepts multiple oscillators and plays back all of them. So in our tutorial, we also have some some other variations that we can use here. So for instance, this bit changes the type. So this example changes the type of the oscillator. By reading the type of the oscillator from a character that so the type of the character, the type of the oscillator needs to come before the numerical value. So you see that all the features that we've defined before are cumulative. Right. The other variation is, for instance, how we can. I forgot maybe to just go through how the type is actually designed in the language. So for the oscillator type, we are okay. So for the oscillator type, we are capturing the one character S or T in the tokens, and we are returning it in this function here. And we're capturing the oscillator type there, and we're adding it as a parameter to the oscillator function here. So this is the bit of grammar, the grammar rule, where we capture the oscillator specification, both type and numerical value. And this becomes the new block, which we will be using in the recursive step, which is here. It's where the oscillator here comes. So the recursive step, the recursive rule with the stop rule here. Right. So this is pretty much our recursion tutorial. We have another tutorial which is for the intermediate language. Let me just check questions. So you guys are responding to the questions there. Okay.
It's often good to hear someone else explain as well. Chris, would you want to kind of express what this recursion tutorial is about? What is recursion here in this?
Yeah, sure. Well, I mean, the purpose of recursion is so we can have a variation in a language. So we don't have to have fixed rules for input. Those rules can have multiple elements, or there can be multiple rules. So it's the way of making a language potentially expansive or infinite, I guess. And I guess the key point in what we're looking at on Francisco's screen right now, the oscillator list and those recursion rules, that you see that structure happening again and again in lots of different languages, maybe in slightly different forms. But if you have a look around the languages that are already on Semma, you'll see that pattern crop up. So that rule is a bit like a design pattern. So if you can get familiar with how that works, then you can keep on repeating that any time that you want a variable length sequence of stuff, which you're going to need probably quite often. So yeah, have a look in Rubber Duckling or the default language, and you see that happening quite a lot. Mm-hmm. The other thing I wanted to mention as well is thinking about workflow around designing languages, because designing languages can be really quite tricky, and sometimes it's really easy to get yourself in a bit of a mess and not realize what happens. I've certainly experienced that, because there's just like quite a lot going on at play, really. You've got a grammar with two languages in already, using that to design another language, which is getting translated into a tree and then another language. So it's kind of chaotic, right? So I think my advice for anyone who's doing this is just to take it really, really slowly. In that recursion tutorial, it starts off from just a ridiculous language that just plays a saw wave, whatever you type into it, as long as it's a number. And although that language is almost completely useless, it's a really, really great starting point, because you know that sound is being made. You know that there's the kind of system you've already got the structure in place for defining the top bit of the tree and defining the output, the audio output. So once you're there, that's you can use that language as a template, as a really good starting point for moving forwards from. And then every time you make a change, even that's really, really small, just keep testing, because sometimes it can be a little bit difficult to track down what's gone wrong if you get too far ahead of yourself. I think that's all I wanted to say about that, really.
Right. I also see that there are people asking about the D values. Okay, so the D values, so let's look more closely into the recursive function. Let's see slide. So the D values, basically, this is the data that's injected in the function, and it's a list. So it's a list, and we're accessing indexes of that list to return another list. So for instance, when people are asking about, so what about white space? So that white space is also has a place in that list that we're working on. And that's why oscillator 1 is D0, white space is D1, separator is D2, and so on. This white space is D3, and the oscillator list is D4. So we're taking the list that we're receiving through this symbol on this rule, and which is a list, and we're concatenating another list that's coming, for instance, from here. Right. Yeah, white space. Okay. Right. Shall we move to the next one?
Yeah,
okay.
we don't have much more time, Francisco, but you can quickly show the key elements of that tutorial.
Right. So in this tutorial, so in the previous tutorials, we've been working with bits of that nested structure, that JSON that is used to build the abstract syntax tree that will eventually be converted into DSP code. But in Semma, we also have some wrapping functions that wrap little bits of that specification and make it more easy to use rather than having to work with all of that nested structure. So, for instance, if you take a look at this grammar, instead of having all that those pieces of JSON, we're working with a set of functions that wrap up those little bits. And for instance, you can see that the notation becomes much more compact and easy to use. So here we have a mixer that is being wrapped and as a list and injected in the DAC, which does the output, and it will return a DAC, which is our audio output, all wrapped up in a tree. And so pretty much the same code that we had before, which was a little less terse. Here we have functions that wrap those bits, and these functions are all documented here on the semi-intermediate language. Where is it? Sorry, Chris. Where was the wrappers?
Right at the end, I think.
Right at the end, exactly. Oh, okay. So the helper functions, they wrap up those values that we had to work before, and they provide more of a terse notation to work with. And we just use them as we used before. Right. So yeah,
Francisco, is it easy to create your own wrapper functions?
Yeah, we can create them here. We can create custom functions here on this bit on the Lexer, and on the Lexer section, and make them available to the rest of the grammar.
Yeah, there's an example of that in the next code bit in the tutorial.
Right, so it's right here.
Mm.
So for instance, to mix oscillators, we define a custom function here, which is on the Lexer definition, and it becomes available to the semantic actions bits on the rules. So we're using it here.
And what is the language command to run it?
The language command?
Yeah, what would you write in the code window to mix oscillators?
So it's pretty much the same thing.
Oh, it's not a new keyword that you've created.
No, it's just like a more compact representation for what we did before, but it's the same language. So it just adds up frequencies and oscillators. Yeah, so I think that kind of wraps up today's session in terms of tutorials. Let's see. Right. So Chris just suggested like a nice list of frequencies. Oh, I can't copy and paste from Slack. Interesting. One time. Oh. Right. Okay. That sounds nice.
Great composition.
There are more examples being pasted by Alshand. Okay, let's. Oh. What? Oh. Is that right? Oh, okay. An invisible character, nothing else. Right. Okay, so I guess this wraps up the tutorial for today.
Yeah, I think Chris was gonna take over now before we end.
Yeah.
Yes. So what do we need to mention? I think the main thing is, well, next week then we're going to be around. If anyone's kind of continuing and wants to get into more depth with SEMA, then we will be continuing to be on the Slack channel, and we'll also be around on Monday, Wednesday and Friday on Zoom in this same meeting link. I think the one on Monday is at 5 p.m. UK time, and the other ones will be at 3 p.m. UK time. So that'd be great if anyone wants to kind of go into a bit more depth, having picked up this material this week, and we can help you out with whatever project you're doing. The other thing is, Thor mentioned earlier the Network Music Festival, and it's really nice when you're designing a system, not just to design it for the sake of designing it, but to have a performance at the end. That usually really helps focus how you're working creatively, and so it'd be great. We've got a slot in the Network Music Festival. I'm not exact. Is it on the 15th? Did someone say? I think Shelley actually just put out the timing, so we'll double check that. But if anyone wants to play, you're welcome. Basically, it's anyone who wants to play can. It doesn't matter if you want to just do a 2-minute set. That's absolutely fine. Or if you want to do a 10-minute set or 15 minutes, that's really good as well. So it's up to you. It'd be just really nice to have a little session of people trying out SEMA. You can use the default language. You can use your own language. You can use machine learning or not. So anything goes really for this session. I'll start up a channel on Slack. Then if you're interested, just say, and we'll get a schedule going nearer the time. I think that was everything I wanted to say, except thanks for participating, everyone, this week. It's been a real pleasure. It's been a great workshop.
Yeah, we've learned a lot, and it's been a great kick in the bum to get our system up and running in a nice way, and it will only be better because of this workshop. We have lots of things to do now, and we're looking forward to fix it up. A lot of the features that you've pointed out are features that some of them we had thought of already, but others are great ideas that we will try to implement.
I should mention as well, Thor, we're thinking about longer term plans for kind of keeping a community and a bit of energy around SEMA. And so I think Thor is going to start a mailing list, and we're going to keep running workshops in the future. And so, yeah, maybe you want to talk about the mailing list, Thor.
Yeah, so I guess you're all familiar with mailing lists. It would just be a low traffic mailing list. Well, all mailing lists tend to be low traffic these days because people are on Facebook and other media. But this mailing list would be good for sharing information, more workshops, a new language maybe, things like that. So if you sign up for it, it'll be low traffic. Of course, we can discuss there as well, but normally these kind of discussions don't happen on mailing lists anymore, unfortunately. But the list is good. It is a good hub for kind of getting this push into your inbox with new information, news, updates, and so on.
Right. We also have the SEMA community on TopLab, so possibly that would be a nice place to centralize our focus resources. So we'll be developing that in the near future, and we will meet there.
So the workshop hasn't stopped. I mean, we are going to be around next week for help with projects and tutorials and ideas and so on. But we're not going to be kind of developing these video. Maybe there's 1 or 2 more videos coming up, but now it's more like supporting work rather than introducing stuff. And yeah, and we're going to be focusing on trying to get some to learn from this workshop by designing a user study and do some interviews. So we really hope that you can join us in those. Yeah, that's about it, I think, guys. So thank you, everyone from all over the world to come and join us in this virtual Zoom space. It's been actually quite nice to run a workshop on Zoom. Unfortunately, we couldn't go and drink beers together or go swimming in the beach, stuff that we would do normally in Brighton. But this is still interesting. It's quite good. So thank you, everyone, and see you next week, maybe.
See you guys. Good to have you. Bye-bye.
Bye-bye.
Thanks, everyone.